Today's video will demonstrate how to insert elements into an unsorted set. Hello, I'm James Helfrich. The unsorted set is implemented with a hash. The idea is we want to have every element be in its own bucket in the hash table. However, sometimes collisions arise. How do we deal with that situation? This video will demonstrate the algorithm how we insert elements into an unsorted set. There are several different methods that allow us to insert elements into a hash. The first is the insert, where we either copy or move an element into the unsorted set. Notice we return a pair, both an iterator to the element we just inserted and a Boolean to see if we did insert it. In other words, if there's a duplicate there, it's going to be false, but if we're going to able to insert a unique element, then it'll be true. We can also insert an element with a hint as to where the element may go, and we can insert a collection of different elements. And once again, a collection of different elements, or we can rehash the hash table. We're going to focus on the insert methods. So let's take a look at how this works. I have an unsorted set that's going to have 4 buckets. First, I'm going to insert the element 67. Notice how there's 4 elements. Since there's 4 elements in the hash, I'm going to take 67 mod 4, and that'll give me 1, so it goes into bucket 1. Then 85 also is going to be in bucket 1, and then 50 is also going to be in bucket 1. In other words, my hash function is not doing a very good job of randomizing where my elements go. But when I rehash it to 5 buckets, then everything gets redistributed. And now my elements are more evenly distributed. So let's take a look at the algorithm for inserting a new element into an unsorted set. First of all, I'm going to find the bucket which the new element will go, and I'll call this iBucket for index of bucket. Second, I'm going to see if the element is already there. Notice that this is an unsorted set, so I must ensure that each element is unique. So I'm going to have to iterate through all the elements in the bucket. Hopefully that's a small list. And if the element is there, I'm going to return false, which means I have not been able to insert a new element. Then I'm going to reserve more space as necessary. In other words, if my maximum load factor is exceeded, then I'm going to have to reserve or double my capacity, which is going to cause me to rehash everything. Then I'm going to insert the new element onto the back of the bucket that's there. And notice I'm going to hope the bucket is empty, but if not, I'll just put it to the end of the bucket. And then finally, I'll return the iterator to the new element that I inserted and true, which means I was successful. Now let's demonstrate how this works. There's going to be 3 cases. The first case is there's already a duplicate element. So I'm going to start with a 5 bucket hash. In this case, there's 4 elements in it. So now I have to find my bucket. Notice how there are 5 elements. The element is 49. 49 mod 5 is 4, so this is going to go in bucket 4. Then I'm going to iterate through all the elements in that bucket to see if the element 49 is already there. 64 is not it. 49 is there, so I'm going to return false. I'm going to an iterator to the element 49, and I'm going to false, which means I was not able to insert a new element. Now, case 2, the element does not already exist, but there is extra capacity in my unsorted set. So I'm going to have the same elements I had before. My bucket number is 4 because 99 mod 5 is going to be 4. Then I'm going to go through the bucket, and it looks like 99 is not there. So here, what's my capacity? Now notice how I have 4 elements in a 5-element unsorted set. Therefore, my load factor is less than 1, so I'm not going to need to reserve. And I'll just push it back onto the end and return true, which means I was successfully able to add a new element. The final case is my unsorted set is full and I need to rehash. So I'm going to have the same elements I had before, 5 elements in a 5-element unsorted set. My bucket number is 4, just like before. I'm going to walk through here and I'm going to see that 19 does not exist. But now my load factor is 1, which means I have to rehash. And how do we rehash? Well, I'm going to double the number of buckets, and I'm going to take all the elements that are currently in there and find a new spot for them. So let's see here. That's going to be 50 and 66 and 64 and 49 and 99. Now notice how there's 10 elements in my hash, so it's basically the last digit for each of the elements is going to be the bucket number. Now, I have to find the new bucket for my element. It was in bucket 4, but 19 is now in bucket 9. So now I'll push back 19 on bucket 9 and return true, which means I was successful. You could learn more about inserting elements into the unsorted set by looking at the hash chapter of the C++ data structures textbook.